All right. Hello there. So this is Chris Bachman over at Cal State LA. So putting together a quick video on some advanced machining, which is going to entail working with Mastercam to turn our solid model into some cutting toolpaths, which we're then going to feed into a Haas mini mill. So if you have access to a Mastercam license, that's good. If you don't, you can actually download this at home, this home learning edition. The only thing it won't let you do is to output the post the G code at the end. So you just have to save the file as a Mastercam file, bring it to whoever has a full license, and then output the G code. So I use this version at home a lot when I have and then I have the full version on my computer at work. So if it's this in-house solution, so if you type in something along the line of in-house solutions Mastercam Home Learning Edition, it'll take you to this page. So once you have the Mastercam installed and fired up, it'll come, it'll kind of fire up looking like this. So first, let's talk about kind of Mastercam, and assume that you're familiar with SolidWorks at this point, or some programs to make solid models. So we're going to talk mostly about Mastercam. So I have Mastercam 2018. We also have 2020 on campus. They look very similar. I'll point out where some of the icons look a little bit different. So first couple of things I want to say about working with Mastercam is remember to save often. Can be kind of buggy, especially when you're trying to simulate a bunch of tool paths and it's trying to compute them. It'll crash on you. So you'll make sure you want to save every 5-10 minutes. The other thing is that its undo function is not that strong. So a lot of things you won't be able to undo. So that'll make saving important. It's easy to accidentally delete things as well. So saving is key, as with a lot of things. Another thing is keep an eye on the bottom planes down here. So in this bar you have your X, Y, and Z position, and you can see right now I'm moving my cursor in the XY plane, and that's because my construction plane is on the top. If you right click, my computer behaves, and I look at the front, you'll see that my construction plane and my tool plane will now change, and I'll still have the X, Y, and Z because of the construction plane being turned, but this will mess with your code in the end. So you'll want to keep this on the top and keep everything the same down here. So this is your construction plane. This is what you're drawing geometry on. This is your tool plane. This is kind of your tool is going to approach along the Z-axis, and then this is your worked coordinate system. Okay, so that's the bottom, along with some different ways the model is going to look. So you see how you can highlight over things, and that'll change the way they look. So you can, if you don't want the full kind of outline solid, sometimes I like to toggle the translucency, and this one can be turned on with the other one, so some can go together. The rest is gonna. So I mentioned those the two important things: saving and keep an eye on these planes. You want them just to stay at top for the most part, unless you're doing something more advanced. The rest of this looks a lot like the kind of Microsoft Office, where you have a ribbon with different tabs that'll bring up different commands, and then they've grouped the commands within each tab. You have this quick access toolbar, which you can, kind of customize both the quick access and this ribbon by right-clicking in here. And I'll go through some of these. On the left, here you have, this will kind of record everything that you've done basically in here. So this is kind of like your property manager to some extent. And this right now is, we're looking at all the toolpaths that we make. We can also look at the solids we bring in. We can look at the plane. So here we can see that we have all of our top is for our work coordinate system, our construction, and our tool. The levels, sometimes you can, if you get a more complicated part, you can, with a lot of different entities like lines as well as solids, then you can make different levels. And sometimes you might have your wireframe on one level and then your solid on another level, and you can toggle between them without accidentally messing with both. So then recent functions. So that's kind of over here. I'll talk more about it later. You have kind of these selection options up here. So this will allow you to select change the way you can select things. Over here, this will help you select a lot of things at once. So for example, this, select only solid entities, select all solid entities, and you'll see, there's like surfaces, this is going to be wireframe. So you can see all the different types of entities, and you can, if you need to select certain ones, you can do that here. So, okay, so going across the top, we have our home, which allows us to change the colors of different things. So you can select them and then change their color. You can look at your different levels. One thing I'll use a bit is I'll analyze distances or analyze an entity to just see at where it's at in space or how big it is. Next, we'll go to the wireframe. So the wireframe allows you to put in some simple geometry. Anything more complex than some points in space or some rectangles or a circle, I'd pretty much do in a CAD program, since I don't really like doing that stuff in CAM. It's just not quite as intuitive. But just for something simple, let's say you want to put a bolt, put a hole somewhere. You might just put a point to tell it where it is. So when you come in, you can select point, and then it's going to ask you to create point position. So this kind of prompt here will come up a lot. And so you could come here and you could select this point and put that point right there. You imagine this would be kind of tough. Let's say most of the time we want to put a point in a specific spot, right? And so let's say I want to go to 1, 1. You see, it's pretty tough to get us down to 1, 1. So what you'll end up doing is just hitting 1, and then it'll bring up this little kind of quick access. And so I'll do 1, 1. So I'll put in the X and Y position, and you'll see it'll put in my point 1, 1. You can also make that come up here with this auto cursor fast point. So then we'll hit check to create those. Same things with a circle, right? So it says enter the center point. So here I could just hit -1 on the keyboard, 1. So that'll put in the point, and then I could hit enter, and then I can now control the diameter, or I could say, oh, I just want a 1-inch diameter. Hit enter, and then I hit check. So now I've got my circle in space. So you can see how you can use that to make some simple geometry that you can cut. You'll see that it will get this kind of crosshatched look. If you want to make things look, you can right click on them, or you can go back up to this home, so they have similar commands. You can change the color of some of these if you want. If you want to highlight, some are red, some are blue. You can select by colors. That's going to be one of these down here, probably this one that looks like colors, right? So now I could select everything that's red, for example. So there's a wireframe. So we have surfaces, so you can also make a surface, right, by kind of a lot of these kind of common methods, basically. One I do use sometimes is fill holes, or basically maybe like fill it between two surfaces, right? So sometimes I'll have a hole in something, but I'm not going to drill the hole right away when I'm machining. I'm going to first go over the top of the hole to machine it down. So then I might fill in the hole with a surface there. And the last one is solids. So typically I'm going to make all my solids usually in some sort of CAD software instead of the CAM software, but you can come in here and try and create a cylinder or a block if you want, but I don't typically do that. Model prep will let you make some modifications to your solids. I've never really used drafting too much because typically use my CAD software for that. The transform is really useful, so this will allow you to move your solid in space and orient it the way you're going to want when you machine it. So that's really important. We'll use that, and after we orient everything, we'll select our mill, because that's what we're going to be talking about today. And then you can change the way things look. So I already have my axes on. I like to do those axes. You can also do F9. So if you hover over it, you'll see it'll say F9. You can also, get rid of certain things, like you can make solids go away and that sort of thing if you don't want to see them. So yeah, so that's kind of an intro into this interface here. So there's a first let me delete this, sorry. So I'm going to select those, delete those. Okay, so now let's start talking about kind of the work process for working in Mastercam. So first thing we're going to want to do is bring in our solid the shape that we want to eventually turn our workpiece into to make our part. And then we're going to have to tell it what stock are we going to start with. And you should keep this in mind that, you need to think about how you're going to machine something or manufacture it the entire time you're designing it. So this shouldn't be the first time you're thinking about how you're going to manufacture it. Otherwise, it's going to be impossible or not very efficient to do. So hopefully you've thought about it before this next step, and you should also be thinking of when you design it, how you're going to manufacture it and how you're going to hold down the stock while you're doing the processing to it. So there's a lot of tricks here in that into things you want to think about before you get up to this point. But hopefully after watching this, you'll kind of have a better feel for what some of those things are. Okay, so I made a couple of example solids. So you can pull in SolidWorks files, or typically what I'll use are parasolids. If you, for example, have Mastercam 2020, that'll pull in SolidWorks files from 2019, 2020 easily. So I actually have Mastercam 2018 still on this computer, and I have SolidWorks 2019, 2020. So this one won't read the future SolidWorks file, so then I have to use parasolids. But otherwise, I'll just leave it as a SolidWorks file. So when you hit open, it's actually going to create a new file. So usually you want to start by bringing in the solid. So I don't need to save my example here. So I'm going to go, I have the file on my desktop. I need to select all file types. And so you see if I try and select one of these SolidWorks parts, just because it's a more recent version of SolidWorks, it's not going to pull in. But these .xt, these are parasolid files. Those will come in okay. All right, so my solid came in. I'm going to check my planes. Planes still look good. So if I hold the scroll wheel down and turn, I can see my part. So this is kind of the example part that I want to make. And so you can see it's not really necessarily where I want it in space, or maybe that's not obvious yet, but I have it's going to be hard to set my 0 point kind of here. You can also see that it's not oriented the way I want. So this will be the kind of top portion in SolidWorks. So it'll actually usually pull out the front in the Z direction. So if you want your part to come out kind of oriented right to begin with, have the side you want to kind of come from machining facing the Z direction. So all right, so first things first, I need to move this around in space. So that's where I'm going to go to this transform. So if you have square things, a lot will be like move to origin, or for example, maybe I had a big hole here and I'm going to indicate off of that to get my origin. So what you might do in that case, so I might just like move to origin, and then I'll just select that hole, and then it'll come and it'll move that right to the origin. So that might be one way that you'll do it, but I'm not going to indicate on this hole. Actually, I'm going to indicate on my stock. You want to be careful a little bit when you say move to origin, because sometimes if you sit for too long, you can accidentally select some of these outer edges and not the actual center point. Okay, so now I could rotate this down in the Z direction. I actually just usually use the translate to plane. So it says select the entities, so I want this solid, hit the end selection up top. I don't want to copy it, I want to move it, right? And I'm going to take this top plane, I'm going to make that my front plane. So that way it's going to be facing up. Let's give me a little preview. So that looks good, right? Still got top, top, top. That looks good. So now basically I need to translate it in space. And so there's kind of some different thoughts on this area. So if I'm going to have my stock here in positive X and positive Y, I'm probably going to touch off my origin here on the front left. So that's nice because the edge finder, or if you're going to use the side of a center drill, it's kind of out front, easy to get to. You might also want to just go in negative Y and positive X. And so you'd kind of, let me move it around, maybe that'll make it what I mean a little more obvious. So if I move this, so we could move our part here, and then we'd have our stock around it, and we could then touch off to the top left. The nice part about that is that you're against the fixed jaw of the vise, and so that's not going to move unless you take it off the table. A lot of people on our campus will do this front left though, and so it's probably just, if you do that, it'll be easier for people to check your work. I can see my Z height is already correct. If it's not, you'll want to move it down so it's right even with the top. So I'm going to make it not even with the top like this. So, and it's not really, so you might not even know, how far off it is. So what I might do is I might go home and do analyze. I can, select a face, or I'll just select this edge. I'm going to see, okay, where is this at? And it tells me this Z is at 0.05 at this point. So, okay, so I know it's at 0.05, so I got to move it down. So I'm going to come down to the transform. I'm going to click on this whole solid. And I'm going to go, okay, I'm going to go negative 0.5. And then I'm going to click check, right? So one thing you might do is I want to look at it from the front. So you might right click and then hit front. Then notice that your construction plane and tool plane got messed up. So that's actually going to mess up when you try and generate toolpaths. So one thing you'll notice, so if you start to, so you'll notice that now, because my construction plane is the front, I'm now making circles in that plane rather than the top plane. So that's what kind of the purpose of that plane is. But again, we're going to want to go right click everything on top, right? So the scroll wheel in and out, if I hold shift and grab the scroll wheel, I can move it around. Also left, right, up, down on the keyboard will also move it around in space for you. I usually kind of keep it somewhat isometric. Okay, so we have our part in a reasonable spot. And I might think, am I gonna put a block of material in here and then cut this out, in the vise? I mean, probably it's probably one way I could do it. I could also, use some step blocks and fingers and hold down the piece right on the table with a little piece of material between it, so that I'm not cutting into the table of the mill. So those are both would both be possible routes to do it. Keep in mind, you wouldn't want this to get real thin over here after you machine it, and this side if it's on the vise, because then it's actually gonna kind of squish your end mill as it's going around. So so let's do this as the case that potentially I have some kind of fingers down on the side, but that means I don't want to hit those fingers, so I have to think about giving myself some extra space on my stock so I don't hit it. So and that also means that that piece of material, you might have to square it off in the machine. You could get just a much larger piece and put this kind of anywhere and not really care about its orientation too. I mean, that's another way to do it. All right, so next at this point we're going to say, well, what type of machine are we going to make this out of? So we're going to say we're going to use a mill, and we're just going to usually use the default. You can bring in your own type of machine, but typically it won't. I won't bring in a specific machine definition. The only thing you might use is this mm. So if you're going to do something in millimeters, you can bring in kind of a millimeter, do everything in that system. So, but instead I'm just going to use the default. Give it a second, and you'll see it'll pop up over here on the left. Let me just make sure everything's recording while I'm still doing this. Okay, we're looking good. Okay, so first thing I'm going to open up is the properties. I'm going to start with the files. So oddly enough, the options button is this exclamation point. So if you see this exclamation point, that's going to bring up some more options for you in these different areas. For some reason it looks more like an error message to me. I don't know why that is, but so this might even be changed in future versions. So here you can have your different libraries, different defaults. I usually don't mess with this. Here's the first thing I'm going to start to modify. So my tool settings. So first thing I'm going to do is, I don't want to pull in the spindle speed and feed calculation, or pull in the feed just from the based on the tool. It should be based on the material, and then this will also use the RPM and the kind of feed per tooth to calculate your feed. Another thing I'll do is I'm going to assign tool numbers sequentially, and that's because if you have a big shop with 240 tools, maybe tool number 240 will always be 240. If you have some huge machine, maybe it'd be more like number 15. But for us, we typically have to load in our own tools for each thing we're going to machine. So we're going to assign our own tool numbers, and we're going to put them in the machine that way. We're going to start our G code with N100, and we're going to step up in 10. That'll help us search through it if we ever need to find stuff. And then you can select your material here. So let's pretend we're working out of aluminum. You can edit this and select different ones. So the last step here will be the stock setup. So I'm just going to start with a rectangular piece. You can bring in your own solid if you want, and you could even add some of your fixturing to it. But I'm just going to use a solid. So what I'll usually do is I'll click this top left. So that basically says that this point in space right now is at 0, 0, 0. So right now I don't have any entities. That would be like those lines or circles that I drew, but I do have solids. So I'm going to click all solids, and that's going to look at this solid and say, how big of a box do I actually need? So I'm going to say, so I can see X on the way by about an eighth, a little under a quarter by Y. So I'm going to make these a little bit bigger by those values. So maybe my Y value is maybe 2 inches big. My X maybe is 3 inches big. And then what I'll do is I'll hit check. And you can see now, because I put 0, 0 at this top left, I have kind of a bounding box for this. Let's keep in mind though, we wanted some extra meat so we can go around the outside. So let's go back into the stock setup. So I'll click there again. So maybe we want actually 4 by 5. So we'll add a few inches onto each one. I'll click check. You'll see it's gotten a little bit bigger. That's probably a little excessive, and we can still transform it. So maybe I'll translate this a little bit more. I'm going to select it to move it, and I'll just use my arrows. So maybe this is the size of stock I'm going to start with. I'm going to clamp it here and here, here and here, and I'm going to give myself some room to cut this piece out. I mean, maybe you just want the pocket on the inside, and then you'd have to, probably, I don't know how, if you already had this piece, but let's say you had a square piece with a pocket, then you would want to position this to an exact point. But for a shape like this, because I want to show you how to cut the outside out, we'll just put it here in space. So okay, so we have our stock set up. I like the top of my stock and the top of my part all to be at 0 and Z, so I can tell when crossing from positive to negative in Z, I'm going to start to cut, and so that's when I'm really keeping a close eye on things. All right, so at this point, you'll see now that once we selected the mill, we have these additional tool paths that are come up, and they're split up into 2D, 3D, and multi-axis. So I'll typically work with 2D and 3D. I'm sure more advanced machinists will use this all the time too, but I don't machine as often as I would like to, but so I'm generally in these two areas. So, and you can see the different types. So contour, you'll select a contour and you can go on the inside or outside. You can also add extra paths. So if you want to kind of create something that's kind of like a boss, you can do that. You can program in drilling in different spots. But let's start with the pocket on ours, right? So we're going to start with the pocket. So this is one area where it looks a little bit different in the 2020. They've just kind of updated these symbols, but they're the same group of symbols. So because we have a solid and we don't have any kind of wireframe entities, it won't even be an option here. So we'll click the solids and we'll be able to select things in 3D. So you can select just one edge here, it'll do a full loop. Here you'll have to kind of tell it which way to go along these different edges. Here it lets you just do a partial loop. You can select faces, the last thing, and this will unselect things or select things. So when I'm coming and selecting, I'm going to come select this pocket. So where I click is usually where it's going to usually start to do the cutting. So I'm going to kind of select a part that's not super sharp, or maybe it can't get in. Here I think I'll be able to get a tool to get in, and I can select the top or the bottom as well. So the bottom is nice because then it knows what depth I want to go. So usually I'll select down in here. It'll ask me, yep, that's the right face. And I want my tool, so here my tool is going to be turning clockwise, so it's going to be conventional milling. So I want to switch the directions, and I'm going to want to do climb milling. So it's going to go along the left-hand side. So I'll click check. So now it knows my contour. So if I ever come back in here and you want to reselect your geometry, you can click on this select change. You can remove and then reselect. So next we're going to select our tool. So I'm going to come in here to select tool library. You'll see kind of various options. So let's come in, and usually what I would do is I'd select none to start. I'll do my kind of flat end mill, and then usually I'll use a less than just to get rid of a lot of the sizes. And you can see I have these options. So let's try a 1/2 inch. So this is tool number 290 in their system. You'll see when I bring it in, it'll come in as tool number 1 for me. And when I call out for a tool offset, diameter offset, this will all be tool 1. So the material brings in 400 surface feet per minute. That calculates the spindle speed. You can use that to calculate these. So usually I'll just use rapid retract. In this case, this is a little bit high, so I'll bump this down to on the order of 10. And my plunge rate's a little bit high. I'll usually do this on the order of 1 to 2. And then you have your force tool change. So this is nice in that if you do 2 operations with the same tool, when you do the second operation, it'll still program in the tool change, which is nice because it's easy to kind of jump to that spot. So this makes it easier to kind of go in. So we're going to keep going. So we have our cut parameters. So in this case, we want to do climb. And so kind of depends on how you want to do the tip compensation. So we want to compensate, and then we're going to select nothing on the wall. So you'll see those lines will go away. Next, we'll go into roughing. So right now, it's automatic method is this high speed. I would either use that, or constant overlap spiral is also a common one to use. And just what you'll basically do is you'll step over 50%, which is a 1/4 inch each time. You have this entry motion, which is usually in percentages of your tool diameter. So here, this is just picking the kind of, instead of having to go straight down, it'll helix down in. So next we'll have finishing. So if we want to do a finish pass on the sides of it, maybe a 10,000ths finish pass. Spring pass will basically be right at the surface finish, go over one more time. So it'll kind of hope that there's a little deflection on a bigger cut, and that your last pass there won't be any deflection, so it'll cut a little bit. I'll usually keep the tool down so that it's not going up and out all the time. If you want to try and clean out the chip more, you might pull it out. And I'm only going to do it at the final depth, so I'm not going to do a finish pass halfway up and then at the bottom. I'm just going to do one finish pass out here. So lead ins and lead out. So you have this entry, which will be come in tangent, and then you'll have this this length. So this will come in a 1/2 inch this way, and then it'll come in at the 100% of the tool and sweep 90 degrees to turn into here. So if you wanted to decrease this to 45, you could kind of come in more at an angle like this and not do the full 90. But typically this is and you could kind of do something here, you can bring it over to here. But the typical setup's usually good here. So next we'll do depth cuts. So maybe we don't want to do the full 1/4 inch depth all in one go. So maybe I want to do it in 100,000ths and do one finish pass on the bottom of about 10 thou as well. And here again, I'll keep the tool down. So breakthrough, if I want to go all the way through, I do breakthrough. Next, and maybe one of the most important things to pay a lot of attention to is on your linking parameter. So this one, you're basically going to tell it where's the bottom. So this one, I can tell it incremental, which basically says that contour line that I picked, I want it to be 0 relative to that increment. I could also do absolute negative 0.25. So here, I'm going to want to do 0 for the top of my stock, absolute, because that's where I put it. So here you can, so there's already, this would cause a crash basically if I didn't change this. So right now I'm saying that the feed plane right here is only 0.2 from the bottom of the pocket. So that would put it like right here. So that means as it would be, rapiding down all the way to here and then feeding. So I like to just make sure I have absolute for all three of these. And then this one kind of depends if I pick something at the top or the bottom of the pocket, then I might do absolute or incremental here. The last thing you're going to select is the coolant. So we have flood coolant, and we're going to turn that on. And so here you can begin to see kind of a highlights of the things that you picked. You can see some of the feed rates, the spindle speed, coolant, and that sort of thing. So we're going to click check. And so you can see our current toolpath right here. So you can see the blue is the feed at 10 inches per minute, and the yellow are the rapids. So you can see it's going to rapid down just a little bit, do all the cutting, and then it's going to rapid back out. So here, basically, we'll start to go and talk about this little control panel here. So you can select all the operations. So we only have one operation right now, and it's selected because it has this check mark on it. You can select all the dirty operations. So dirty operations will have an X, which basically means it needs to recalculate them. You can regenerate all selected operations, regenerate all dirty operations. This is a common one since if it's dirty, it needs to be regenerated. You have backplot will just give you a quick view of the tool and the toolpaths relative to your solid, but it won't simulate the cutting. If you do verify, that'll do the simulation. Before you click that, I'd like to save, and that's a good reminder that it's always good to save. So I'm going to save this. So this is my example part. I'm going to save it on the desktop. All right. You can change this in simulator options, and then you can kind of post the G code. Here you can lock certain operations if you don't want them to be messed with. Here I can turn on and off the cutting toolpaths, and this insert arrow, so wherever I add more operations is going to happen below, and I can move that arrow around here. So those are the common ones that I use in this little. If you kind of want to check the rest out, just highlight over the top of them. So let's try and verify it. So all right, so you can see our stock, you can see our tool, you can see the tool position, right? So let's make this full size. So you can see I'm a quarter up. I'm at my retract plane. And so before I run this, you can look at, we don't have a very long thing to simulate. The whole thing only takes 2 minutes in real time, so I'm going to have it go rather slow. And so you can modify how slow or fast it goes, and depending on your computer, you can change the performance. For my work computer right now, it's not very good. And okay, a couple other things we're going to do is we're going to want to make some stop conditions. So we're going to want it to tell us if it's going to crash. So I'm going to open up stop conditions. Whenever we change operations, I want it to stop. If I do a tool change, I want it to stop. If there's a collision, I want to stop. You might have some tool inspection points. I don't have any, but you could select that. So the other thing that I would like to do at this point is I got to remember where this is now. Options. Yeah, so options at this point, you can come in here and you can say collision checking, right? And so so basically now I want to select what things do I want. So if the tool collides with any of these, any of these or any of these, so any types of collisions, I want it to tell me about. Okay. I just updated my defaults. Other thing I'll do is I'll come into the collision checking here. This is probably actually what I meant to select, is I want it if it hits the shank or if it hits the shoulder, I want it to tell me about it. Okay, so learn something new every time. So if you select this options, so this would be your tool just hitting your workpiece and not your stock. So you actually don't want these selected. So what you actually want is in this verified, this one, where you're saying that if you, no matter where it hits on your stock material, it's gonna find those collisions. The other thing I like to do is do the color map. And so what that'll do is if you do multiple operations, you'll see how it comes in handy. You'll be able to see the different operations. So at this point now, we're going to come and we're going to hit play. Kind of see our stepping down. So there's our pocket, and so it's smoother than that. It's just my performance is so low that it's doing it in that way. And you can tell my tool is not that big, so there's not much room for doing a helix down into it. So if, for example, we wanted to switch out for maybe a 1/4 inch, and see what that one looks like. So we come to a 1/4 inch, and then we're going to check. Then I'm going to see now it's dirty, so I'm going to regenerate it. Let's go back and let's re-verify it. So when we come in now, hit play. It'll load fast. I guess you can't really see the helix as much there, but you can see the helix now in terms of it helixing down in each time. So now it actually has a helix. It actually has a little bit of a lead in. So maybe that's closer to what we want right there. So next, maybe what we're going to do is come in and drill these holes. So what we can do now, so we put our insert here. I'm going to click down, and then I'm going to select the drill. So we'll select drill. So we want to drill points. So see how I can actually select this bottom point, which I won't drill in the center, which I don't want. So I actually just like to come and I'll just come up kind of in the top right and click, and now it's going to give me center. And so that means let's drill this one first. And as I come over here and click drill this one, then it's going to come over here and drill this one. Then it's going to come over here and drill this one. Make sure it's got the centers of each one. So that looks good. Click check. And it's going to do it in those 3 orders as you see. So the tool here. So select tool library, my filter. Let's add a drill bit. So let's see which one this is. Actually, a drill bit, spot drill right here. So we got spot drill and center drill. So we're gonna tool diameter less than maybe 0.3, because I'm gonna want. So let's open this up. So I'm gonna want usually this number 3 center drill is the one that I'm usually going to use. So I'm going to click check right here. So it's going to bring in my surface feet per minute for that. It's going to calculate my spindle speed, my feed rate, which is going to be a little bit high here. I'm going to want, maybe we'll just do like 2 inches per minute, because we're feeding down into the piece. We can go back into linking parameters. So at this point, I'm going to do absolute, and usually, so I got a 1/4 inch tip, so maybe I'm going to go about 0.2 in, and these will all be 0.1 from the top of our model. So this, and that should be negative, right? Negative 0.2. So 1/4 inch wide, I'll have a 1/4 inch tip, so I'll go about 0.2 to give me that nice cone kind of countersink for my drill bit to go into. So next, I'm going to turn on my coolant on. I'm going to hit check. So you can see it's going to come here, 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 and here. I'm going to do those points, and then I'm going to come through right after. So if I want, I can right click on this and do copy, and then I can come in here and paste it in again. And then I'm just going to come in almost the same thing, but this time, right, maybe I want my, I think I have a roughly a 3/16 hole in here. So I'm going to do select tool library, filter. I'm going to want my spot drills. Hopefully I have small enough spot drills in here to do this. Oh, it's only got kind of small spot drills. So let's so if we want to, so we'll come in, we'll put in an eighth, and then we're gonna or quarter, and then we're gonna modify it. So we'll hit this spot here. So we're gonna say actually, so you can see. So let's come in here and select the 3. No, let's not. Let's do 3/16. We'll do yes. And then we're gonna have to change the the drill diameters here. The overall length maybe is 3 inches. Cutting length is 1.5. So we'll bring in, this is typically going to be around 118. If I can recall right. So maybe click on these, you can see the different things it's telling you about here, and then we're going to click finish. So we're going to change the name of this tool. So this will be 3/16 spot drill. Brought in the same parameters from before, which is going to be close to, it's close enough for what we're going to use, what I want to use. I'm going to click check. Then we're going to have to regenerate to fix this one. Okay, so what we're going to do next is we're going to verify the selected operations. So what you can see now is what I didn't want to do is it's just going to do the drilling. So if I close this, what I basically had to see, this is which ones are selected, right? So before I verify, I might want to select all operations. And then I want to hit verify. One thing you can do if you want to move these around, for example, if I drag this up and put this here, it's going to bring this above it. If I bring this back to here, it's going to put it here, right? So that's what I want. So if I want this to be under number 1, I'm going to drag it to 1, and it's going to go under. So I'm all selected. Let's verify. So I have my 1/4 inch end mill, and then let's hit play. Right, so now it operation change and a tool change, and so now it's going to come in, and we're going to see what we're going to do with the center drill, and you would see this is going to be blue, and this one's going to be purple. So we'll see the different. So it basically did those 3 holes, and then it's come through, and it's going to drill for those ones right there. So one thing we want to do, right, is we're going to change our linking parameters. One thing, because we'll probably want to drill all the way through. At least not, we don't want to go too far. So that's one thing I can tell we can change here. So let's close this. So we have our parameters. So I noticed that I didn't change this all the way down. So I'm going to go absolute. This whole thing is ½ inch, so I'll do -0.5. You could compensate for the tip, right? So here's this 118 degrees, and the breakthrough amount, so about 10 thousandths. So that looks good to me. So I'm going to regenerate that dirty operation. I'm going to select all, and then I'm going to hit verify again. And I'm going to bring up the performance just a little bit, just because that before is getting a little crazy. All right, so we got a tool chain, comes in, it does those three spots, and then we'll come in with the 3/16 all the way through. So that looks reasonable. No collisions. I can look down in the bottom, right? I can look from this angle and see how far down below the part I'm going. So that's that 0.1. So let's look at a couple examples if we did something wrong. So, so one example for doing something wrong might be, let's say this hole was actually much deeper than the actual end mill could cut. So let's say this cut, instead of having this 0.5 inch cutting length, let's say it was surprisingly short, 0.1. So keep in mind, typically you're not going to have a thing that's 0.1, but you might want to do this where it's 2 or 3 inches deep, which you won't be able to, which will cause issues because you don't have a cutting length that's that deep. So we come in here and we now do verify. Because I came in here and I added the shoulder, the kind of the section of the mill tool between the shank and the cutting length, checking for collisions basically. Now it'll essentially, when I do this, you'll see that it's going to give me a collision warning. So it'll do first. So it took a little bit, but you can see that it begins to notice all of these collisions inside of here, right? And so that's the one nice part about having the collision detection on. So let's go back here. Let's put this back to typically a 1/4 inch. We'll probably have about a 1 inch cutting length, so that's more reasonable. Generate that. Let's say we also did something wrong. Let's say we're on our linking parameters here for this, and I forgot to or maybe let's do one that's even easier to accidentally do. Let's yeah, just based on our geometry, it might not be as much of an issue. So let's go to this one actually. So say on our linking parameters, let's say we could do 2 things wrong. We could put our top of our stock as -0.2 essentially, and then that means it's basically going to at high speed run into our part here. So let's regenerate that operation. So let's try running it now, see what it does. So it looks like there it did not detect quite right that we had so it was unable to tell that we had a rapid going down into our tool here, into our part here. So so that's one thing you're going to have to really be careful of, right? Is setting these portions right, because it didn't realize that even though it was doing this yellow rapid in here, that it wasn't gonna crash. So see if we can do this more. Let's try to make this more pronounced. So it looks like it'll bring in the yellow where it's where this edge of the bit's going to be before it's kind of rapiding. rapiding over. I wonder too if it's just also getting smart enough that it's realizing that what I did here is wrong. But so we're going to put in 0 here. So let's look for another error. So let's say we didn't actually retract up enough. So let's say this was negative 0.4, and let's say this was negative 0.1. So let's regenerate. So another thing that would potentially go wrong would be that now we have rapid movements inside our part. So that would definitely snap the strobe lid off. So let's watch this one here. So I'll bring this one a little bit slower. So it's going. So there. So now it realized that the side of the tool instead of the tip was running through the material, and so we had a collision, right? So it'll pick up. So it picked up that mistake. So that's another one you want to be careful of. One thing you might want to do is a lot of time you're going to want a peck drill, especially if you're going to put any sort of length in. So in this case, when I peck, typically you'll probably want to peck roughly the diameter of the drill bit. So maybe I'll do 0.1, something like that. And so now it'll go down and then up again, down and then up again. So the pecking is kind of the typical process to do for any drilling of kind of depth that's more than maybe half the diameter of the drill bit, something like that. So here's our part so far. We have all of our holes, and so now what we might want to do is we might want to come and cut this thing out. So what we're going to do is, for some reason, when you want to do tabs, the tabs are not going to recognize this outer contour. So what we're going to have to do is flip our part over. What I'm going to do is I'm going to say I want to, wireframe, and I want to turn this outside edge into kind of wireframe entity. So I'm going to select curve all edges. I'm going to select this face, right? And then I'm going to click check, end selection, and check. So now I have a line here. I also have lines on my circles too. So what I can do now is when I come to my toolpath, so this time I just want to come in and I want to mill around the outside. I'm going to do my contour. This I want to do the wireframe here. So I want to select this edge. Maybe I want to come in from this side, my contour. And I'm going like this. So this is climb milling, which is good. Here I'll have options. I don't know why this exclamation point is options again, as I said before. So in tool, this case, maybe we'll use our 1/2 inch end mill because we need to go a little bit deep. Again, I'm going to force the tool change. I'm going to do a rapid retract. I'm going to get my feed rate down something, close to 10 for this, and 1 on the plunge, something around a thou per feed per tooth should be fine. We're not in a big rush, just making one of these. So then we're going to go to the cut parameters, make sure there's nothing on the walls, and then what we're going to do is might get rid of any lead in or lead out because we just want to cut it away. We're going to come to the linking parameters. We're going to say we're going to want to go all the way down to the bottom. 0 is the top, and I can leave these two as absolute. Otherwise, we'd have some crashes. Next, we would like to leave some tabs though, because as we cut this out, we can't let it fall. So then it's going to break our tool. So what we're going to do instead is we're going to add a few tabs. So we're going to add a few tabs. I usually like to pick the tabs myself. So this is a side view of the tab. So it's going to come in and do an angle. I don't need an angle, so I'll just have it go straight vertical. I just need a partial tab. That's fine with me. So I'm going to manual, and I'm going to select the midpoint. I'm going to come in here and do position. So I'll maybe do one tab per side. So I'll click, so this tab is way too big. So let's go back out. So 1 inch big is way too big. So let's do 0.5. Not negative 0.5. No, 0.5. And then we'll do the position. So now I'll select it. Even that's probably on the big side, but maybe we'll just do 2 tabs. So I'll do 1 tab there, and then I'll select this chain again, and I'll do 1 tab on this side. And I'll press enter when I'm done. Find my 2 tabs. And this one I'll maybe also do a breakthrough. Maybe I'll do 20,000 breakthrough just to make sure I actually get the whole thing. So I click check. It looks good. So it's gonna, I only did it looks like in 1 pass right now. So that's maybe the only downside. So I'm gonna click again, and I should have gone to my depth cuts, and I don't need a finish cut, but let's go down 0.1 per time. So we have to regenerate the dirty pass, and now you'll see I'll have multiple passes, and I'll just do the 1 kink at the bottom. So one thing, now that I have my 4, you'll see I'm going to want to put in my tools usually in the order that I'm going to use them. It's easier for me to remember it that way. So what I'll do at this point is I'm going to right click on here and do edit selected operations and do renumber the tools. I'm going to start with 1, and I'm going to increment by 1. And I don't want to add any numbers to these offsets. So now, oh, that was weird. That's because I didn't select them all. So look, so that'll also happen too when you're trying to delete things. So reminding of accidentally deleting things, let's save it at this point. So I have them all selected, right click, edit selected operations, renumber tools. All right, 1, 2, 3, 4. Looks great to me. Let's verify the selected operations. So we'll see the different colors. You can see kind of the respective length of time. Total time it'll take to machine this is 20 minutes. So it's going to come in there. It's going to mill out, hog out this section. Tells me, okay, it's switching its tool. Looks like it's above. That looks good. Come in. It's going to poke those 3. Another tool change. Come through, peck all of those. Now we're going to come through and use our 1/2 inch end mill. So our 1/2 inch end mill will come around the outside. Figure these out. And you can see the kind of the different colors from each one of the tools that we're using to cut. All right, and you can see the 2 tabs that we left so that this piece does not fall in. And you just got to check now, like, all right, if you have some fixturing holding this here and here, you want to make sure that you're not running into it at this point. You might try and have this in the vise. It's not much material over here, so I'd want to move this and have a nice chunk of material on each side inside the vise, so we're not just pressing on these little tabs, because right now we'd probably just, if we were pressing on it hard, we could just kind of, with the vise, we could pop this part out. So, so far that looks pretty good for making this part, and we've kind of gone over some of the standard pockets, drilling, and the contour. Some other stuff you might use is facing things off. The other thing you might use with contour, I suppose, is the multi-passes. Sometimes I'll use. So let's say I actually want to make more of like a boss, or I wanted to make it bigger. I could do maybe 3 of these passes, and maybe do them at 50% of the tool diameter. And then so now if I regenerate this, you'll see now it'll kind of step out. Of course here I'd start to hit my vise and stuff, right? So So that would not be desirable. But there are cases where maybe I want to make a boss or something, and I'll do this. Let's do the backplot on this operation. So one thing we'll test is doing the backplot. So this one will control the speed of it. You can kind of quickly go down and click the info and get the time. So this is now 28 minutes. And we can kind of quickly see where the rapids are. So it's kind of starting at the outside, going to the inside, it looks like. Cutting this. Alright, so I can close the back plot. So that's just kind of a quick way to check on things, how things are going. So we'll remember to save it at this point. So now that I've talked a little bit about some of these 2D, I'm going to just do a brief thing on some of the 3D 3D parts. So what I'll do is I'm gonna file open, and this I'm gonna use my example 2 part. So let's open that part here. So what I've basically made here is, let's say I have a part and I have some sort of kind of roughly random protuberance and some kind of random kind of pocket that I want to be able to machine out. So same things apply, right? I'm gonna have to turn this so that it's up in the z-axis. So I'm going to go back to my transform. I'm going to translate to plane. I'm going to select this solid, right? And then I'm going to then come down to the front, right? And so when I click and I want to move it and not copy it, now I can have this point here. So what I might do next is, one way to quickly move this all the way down over here is I could click this point, move that to the origin, and then the last thing I'll do is I'll just translate this entity down. So what you can basically do is we'll end the selection, and then I'm just going to move this down. Check, so that the whole thing is below the z-axis. Let's check here. I don't even know if this analyze entity will really work. Yeah, it's just too complicated of a shape. We can right click and then do front view, and we can see that we're under our stock, but when we remember, we'll go right click and go back to top, so that we keep our planes in the right place. All right, so we're going to go back to machine again. I'm going to go back to the mill and default. So what that's going to do is that's just going to bring in the default machine. And the same thing we did before, right? We're going to go into our tool settings. We're going to calculate the feed from the material, assign tool numbers sequentially, put in our material, start with 100, increments of 10. So we've seen that all before. Next thing we're going to do is do the top stock setup, right? We're going to bring in all the solids that we have at this point. I'm typically going to take this point. Let's say this is 0, 0, and 0. This might have to be a little bit deeper, so 2.1. This might have to be slightly. No, these should be the right sizes. So now we have our stock set up. You can see that so we'll start with a little bit bigger stock, then we'll machine this out. So let's say maybe we're just going to be holding this on the side in the vise. That's the way this is going to be in. So we could actually do this like this without having extra overhang material to clamp it down. So again, I'm going to save frequently. So this is my example part 2. When doing some 3D machining, instead of the kind of the 2D toolpaths that we were using before, we can start to look at some of the 3D toolpaths. So when you open up the 3D toolpaths, you'll see there's 2 groups. There's the roughing group and the finishing group. So the difference between the two is the roughing will actually look at where the top of your stock is, and it will calculate kind of each step down in Z to remove that material. The finishing will just come down near the surface that you select, and then it will do 1 or 2 passes depending on what you program. So now that we're doing 3D type cuts, we can start to look at some of the different styles that they have. What you'll notice is most of them will keep one axis constant, or at least one direction constant, and then move in the other directions. For example, you can see like the pocket and the OptiRough generally kind of work down as constant Z, so they'll kind of step down. The project you can take a portion of your geometry and you can just project and cut along that plane. So here you've projected a plane onto this cylinder. Parallel, you can pick a direction to go in. So here's like, for example, going only in Y, and it's stepping down in Z. You can see the plunge, where they keep X and Y constant and just move in Z, for example. I typically like to use the OptiRough. It usually seems to work pretty well just to get rid of a lot of material. And then in terms of finishing, you might want to be a little bit more careful on what you pick. So when it's moving in, when it's holding one of the directions fixed, you kind of think about building it like layer by layer. For example, you could build it layer by layer going in the Y direction, or build it kind of layer by layer going in X, or building it layer by layer going in Z. And that'll kind of give you different roughnesses. So a good shape to think about this is actually this kind of triangle here. So you can see in this one, you'd actually want to build it layer by layer going from the front to the back. And that way, when you do that, you would actually have a perfectly sloped surface across the face here. Whereas if you built it layer by layer going from this right side to the left side, you have little steps along the face. And the same thing if you built it layer by layer from the top to the bottom. You have little steps from each layer, right? Kind of think about like 3D printing. So that's why, for example, this raster allows you to go parallel along this surface right here. And basically it's moving along this kind of constant direction relationship in X and Y as it goes across the face. For example, but like this waterline, this would be good to build in layers up from top to bottom. So that's why they're doing constant Z. And so you can think about it that way. I personally, in order to kind of be able to do a little bit of both, I think a good combination kind of roughly is usually this OptiRough and this hybrid. I've also seen times where like radial or spiral could work to your advantage if you're doing something more round. But yeah, so there's a lot more here than I even know about or have experience with. So if you're going to do some complicated 3D shape, I'd suggest reading up and trying a few, or kind of contacting an expert who does CNC machining for a living. All right, so we're going to get started with trying out the OptiRough. And so we'll just do the optimal rough. For now, we want to tell it what we want to machine. So we're going to machining geometry. We're going to tell it what we want to machine, and if we want to leave any on the wall or the floor. So when I come in here, I might select this surface right here and do end selection. And maybe we'll double click, and we'll want to leave the 10,000s on the walls, and that way we have something to come up and finish on. So if you're going to do some 3D, you're pretty much always going to want to use a ball end mill. So we can go to the filter, none, looked like I already have the ball, less than 0.6, and that's really so you can just get a tangent to the surface. So we're going to click check here. So let's just try the 1/2" ball end mill. Sounds reasonable. We're going to force tool change, plunge rate about 1, feed rate of about 10. Oops, not 1p, 10. About 1 feet per tooth of about 1. Maybe if you want to could go faster than that, but using our machines, we'll leave it like that. Um, so there's a lot more cut parameters in here than even I'm familiar with, but if you really wanted to optimize things, I would step through each and every one of these, making sure that it was something that was reasonable. Um, uh, you know, checking the sides. But for a lot of this 3D stuff, it's gonna do a lot of this stuff kind of automatically, and then we'd add on the coolant, right? So let's do kind of a check. So when it has this little green thing, it means it's calculating. So you can see now, the complexity of the tool movement. One other thing you'll notice though is it didn't really actually cut anything except for around it. So I'm going to save it at this point because when I verify it, there's going to be a lot of movement here. So a lot of processing, so it could easily crash. So I'm going to be patient with it. I don't want it to crash. I'm going to make sure I still have all my stock conditions. Make sure I still have my collision checking, got my color map, that looks good. So let's try this. Probably want to go a little faster in this case though, because this is until already 48 minutes just to try and do this. And so, I think that's really going to define your kind of is how fine it is these heights here. So you can see here we have a collision, right? Our tool is not deep enough, right? So that's one thing we're going to need to change. So we'll need to have to come in here and make sure we get a 1-inch ball end mill with maybe a 2-inch cutting length, right? And then we'll regenerate the path. Right now it's computing, right? No, it's done. It's got the toolpath. So let's do the verify. So you can see it comes down here, but this is kind of not what we wanted. So let's so what we want to do actually is we want it to actually get this whole entire surface. So I'm going to delete this, and I want to be able to select not what's inside of here, but I want to make this whole thing flat. So what you can do is go to surfaces and you can fill the holes. And so you can either select a surface or a solid face. I'll click this one. And I don't want kind of the boundary though. I don't want this boundary. I want this boundary over here to be added. And I select, all right, I'm going to fill that in. So I click check. So that basically means it's going to fill in that face. So now, if I want to choose this roughing, I'm going to select things. I might select this, this, and that. I'll leave that in selection. Right, I'm going to still use the same tool. I'm going to use maybe about 10. We're going to up this. We're in aluminum, so 300. Plot rate of about 1, 10. And we'll keep all of this the same. So we'll regenerate it. So you'll see the different heights that it's working at now. So maybe we want to go a little bit finer. So let's go into these parameters, and let's do these cut parameters. And so what we see here is our step down is pretty high, right? So we can take this step down to not 150% of our tool, but let's do like 10% of our tool. So that way it's about 50 thou. So we'll regenerate the cutting tool paths. So it's going to take a little while because now there's going to be a lot more, but we'll get some more. Hopefully my computer doesn't crash when it tries to calculate all these. Oh, so now you can see that. So we definitely upped the time though, right? So we do the back plot. Do the info tab, we can see we already got 4 hours just to do this little tiny part, right? So you probably, hopefully your part's not this complex that you need this much, but let's, for the heck of it. All right, so let's give this a whirl. All right, and so there's our kind of roughing, and you could, we could even maybe decrease this for our roughing. So maybe we'll get this at 5%. Check that, regenerate it. Okay, and so now we'll see in our back plot, looking more at 1 hour. All right, so cut her down pretty good. And then we're going to come and do our finish pass. So now we're going to select here. So it's similar to like this opti rough. You have this kind of hybrid. So this is, this is kind of going to step down around the outside of something. Here it's going to pick a direction. So you kind of have the same, which direction are you mostly holding constant? So we can use the hybrid, which is kind of a mix of them. And so you'll see it'll look again. If you do happen to get something going down along the sides, we can tell it to avoid that. Again, we'll select this top surface, this face, and this surface. We probably actually wouldn't even need to really finish this one, but we'll just do it to keep it all at the same level. Tool, use this 1/2" ball end mill again. It's pulling in some of the similar parameters of last time. Again, when you're doing this, you'll pay more attention to these exact values. Cut parameters, you can see it's going to go down to about 50 thousandths. And then, so let's go check. Just calculating it. So yeah, so we have more of this roughing to get most of the material out, and then we can do kind of a nicer finish pass. You can see that's going to take forever, right? So if we do the back plot, so 1 hour 57 minutes. So it's going to jump around a lot here with a lot of rapids. So let's select them all and let's verify. So hopefully you're not making a part that's this complex. Hopefully you made a better design than this, but you could see if you've had a curved surface, this would help. And you could try some of the different techniques if you want to see ones that seem to find that were a little more efficient. So this is coming in, just kind of roughing the part out. All right, so we got a tool change. Now it's kind of coming in. You can see where it's left a little bit of material, right? It's coming in. It's going to smooth off this top surface, right? So that looks pretty decent, right? So, oops, see, error message, right? So it's a good thing we saved not too long ago, because it's probably so. Good point to remember to save. So now let's do that case, but let's actually do it so we actually want to mill down inside of here. So I don't need the surface anymore, but let's pretend like it's there, because sometimes you might want to mill flat here and then mill under there. So I'll show you how to select that. So when you go to select it now, I'm going to make sure you have it select so it's translucent, so you can see down in there, and then it's Control, double click, and it'll let you select down inside of there, top surface and this top surface, right? So we can end those selections now. Inside the cut parameters, right? We're still at 150%. So that's so maybe we want 50%, something like that. And we would turn on the cutting fluid and stuff, right? But just to kind of show this as an example. So now you'll see it'll come inside and it'll do this part. So let's save it. Let's verify it. So running the program at this point, let's speed it up. right? So that took us an hour and 23 minutes to kind of rough out this shape like that. Okay, so at this point, I'm going to uh, open up a different, go back to our first part. So now that you saw those, let's look at, what do we do now that we'd want to actually generate the G code for the part. So if you're at home, you'll save this and you'll have to bring it on campus where you have a full license, and then you can do post. So this will turn it into an NC file. So it'll have a .nc extension. We'll click check. It says not all operations have been selected, so you'll want to select them all. And so, but it's good, it now catches that. So we say, yes, we do want to post them all. So this will be my example part NC. So I'll go to my desktop, save that there. And then it's got its little code editor. So because we don't have the exact kind of default posting that we'd want for Haas, we'll have to make kind of a small modification to the code in here. So so you'll see that you'll have your code number. So you have a O and then 4 zeros for your part number, and then you're going to have kind of your different setups. So we're going to go in inches, G0s, rapid. We're going to working in the G54 here. G43 is bringing in the is calling a tool offset, and then it's going to pull in the height of your tool 1. It's going to start at Z.25. So you can see kind of all these movements. G1 is a linear movement, kind of straight down. G2 is a clockwise arc movement, and so forth. So the one thing we don't want is this A0 dots, because for the Haas machines, it's going to think you're going to want to turn on the A axes, which we don't have. So we're going to have to replace A0 dots all with nothing. So we'll just do replace all. I found 8 of them, and it just gets rid of those. And then so we'll have to resave it. And so at this point, you'll be able to run your, copy this over to your USB, and then take this over to the machine. So that's bringing that over. All the other things, sometimes I use, maybe if I want to kind of put some letters on something, I'll use this kind of function, and you can change a lot of the dimensions, right? And so you can kind of click where you want them to go when you click, and then hit check. And then if you want to, you can then go to Toolpaths, and you can engrave, or usually I just contour with a part, and then I'll usually do one of these kind of like window selection methods, basically, on this part, and then the start point maybe is up here, right? So that's gonna select these two. You can see some of them that we don't want, right? So so if we want to kind of begin to kind of try and only get, one of your options is try and just get it so you can get the bounding box to only highlight those entities. All right, so that's kind of one easy option to try and select it. You can also kind of come back in and click things to unselect, but I find it's just better to find a way to select all or delete the entities you don't. Delete the entities you won't need, or just come and click through the ones you do. So you can click through here, and the only thing you'd want to make sure you'd want to do is this on this kind of compensation type. Basically, you're just going to want this to be off, so that it's going right down the middle. Otherwise, it's going to be down the sides, right? So so that'd be one other thing that so I didn't select anything anything yet. So so that would be one way. You could kind of like write some letterings. You'd want to select engraver. So select this and delete it. That would make things a little angry. So you can you click on things to get rid of their color or the last thing I guess I'd want to show you is potentially so one thing I'll accidentally sometimes happens, I'll have all selected and I'll right click on here and I'll hit delete and then hit yes, and I'll accidentally undelete everything that I have, which will be really a little bit annoying, right? And then you try and do Control Z and it's not bringing back your operations, right? So that's one reason to save a lot. Another thing that we sometimes use is, so let's come in here. I'll put in a rectangle. Select first corner position, so maybe I'll do 1,1, and the second corner maybe I'll do 2,2. So we'll do a 1 inch by 1 inch square. And let's say I wanted to mill this toolpath out. So let's come in here and I wanted to do a pocket, right? So I'm going to select this wireframe and I'm going to go along the left, so that looks good. And so what happens when I first come in with a 1/2 inch flat end mill, and let's go down 0.1, all these up. All right, so this is going to come in and cut this material out. So let's verify that one real quick. So let's hit check. So you see it'll leave these corners, right? So what if I wanted to come in with a 1/4 inch end mill and finish that off a little bit? So, but I didn't want to remill all the inside, right? So, so what happens, I'll do another pocket. I'll select this chain again. Right, this time I'm going to choose my 1/4 inch. Check. And you'll see it'll do all these cuts. So let's get rid of this one so we can see it. So it'll toggle those cutting toolpaths off. So you see it's cutting all this material on the bottom that we really just want to come and remove these corners a little bit. So I'm going to come back into parameters, linking parameters, and actually make sure we're actually doing it to that depth. So we'll do -0.1, absolute. And what you can do on this cut parameters, the pocket type, you can select remachining. And so from the previous operation, we'll select 0 to leave on the walls. All right, now check. Make sure this was 0 on the walls too. 0, check. So we regenerate all the dirty operations. And so now it'll ask, now it's trying to think the remachine. So that looks right. So I'll press enter to continue. That's finished tool, that looks good. Remaining stock, that's right. So this looks pretty good at this point. So let's try and verify it. Oh, so the ball end mills. That's not a ball. So it comes in then and there, does that part. We'll slow it down a bit so we can see this last part. And this one's going to come in. So it's just going to come. It's going to peck away at these corners basically. And that way it doesn't have to try and machine the whole bottom, but just the parts that know that's left. So do it fast. Remember the other things that we want to do is I like to have the color map on, and then so now I can see what comes to this, and I can see what's going to get cut away with the blue, right? And so that helped me get a little bit more sharper radius in the corner. Right click and hit fit, get this here. So yeah, so that's a little bit about the different things you can do in Mastercam to program. So after watching this, hopefully you'll be ready for kind of an in-class workshop where we can begin to actually work on some of this stuff, and you can begin to play around with the tool. But yeah, I would definitely encourage you to talk with a lot of the machinists on campus or students who use the tools more than you do to kind of learn more, because this is just a really quick run through and just hopefully will get you started on thinking about some of the different things you can do. All right, well, good luck and be careful.